This presentation covers cyber operations and risk management for Project 3. My name is Jonathan Luckett, and I represent Team 4 New Zealand, HITEMA. In this presentation, we will cover these four main areas: software assurance concerns, system development lifecycle and key attributes of specific methodologies, supply chain risks, and mitigation of those risks in the supply chain. Software assurance is the development and implementation of methods and processes for ensuring that software functions as intended while mitigating the risks of vulnerabilities, malicious code, or defects. Depending on the type of SDLC model utilized, there are several assurance concerns. Some concerns are no feedback loops allowing object modification. Developers will prioritize features and customer satisfaction over cybersecurity. And less organized documentation will make it more difficult to conduct code reviews to identify and remediate vulnerabilities. Other concerns include the following. Module software reuse between applications means more applications are susceptible to exploitation when vulnerabilities are identified. Focusing on financial or organizational risk at expense of cybersecurity can drive priorities away from secure coding fundamentals. Customer-driven methodology will prioritize customer requirements and user experience, which can compromise security. And finally, complexity is the enemy of security. Reusing components allow vulnerabilities to multiply across projects. SDLC stands for System Development Lifecycle. Think of SDLC as a methodology or framework for developing software or implementing a system. It's a structured way of ensuring all stages of design, development, and testing are taken into consideration. Key attributes of a successful SDLC implementation include JAD, Joint Application Development. This involves customer integration, close interaction between customer and developers, and enhanced software quality. Lean development is another successful SDLC model. Lean provides the following. It removes unnecessary development stages, it prioritizes essential functions, and it increases cross-team collaboration. A supply chain is a chain of processes required to supply a commodity. It encompasses every step in the journey of the product, from conception to customer. In the software supply chain, it's making sure that the right code is being developed for the most important features of the program. Analyzing quality and security of the open source components of a software product is equally important. This includes factors such as documentation, support, licensing, and security implications. Examples of supply chain risk include copying, tampering, theft, and insertion of malicious software and hardware. NIST has published Special Publication 800-161, Supply Chain Risk Management Practices for Federal Information Systems and Organizations. Organizations can utilize this document to ensure supply chain risks are mitigated. The document focuses on four areas: integrity, security, resiliency, and quality assurance. Mitigating supply chain risks include the following: establishing security-focused protocols, policies, and development methods at each stage of the software development lifecycle, assuring that the integrity of communications processed both internally and externally is not tampered with or disrupted. To ensure the long-term viability and availability of telecommunications services, testing should be implemented at each stage of the software and system life cycles. Removing threats to the security, integrity, and availability preserves and/or increases efficiency, reduces the possibility of cybersecurity breaches, and improves the organization's reputation, consistency, and cost effectiveness. The following recommendations are consistent with best practices for software development projects. Application security assessment should be integrated into the application's software development lifecycle. Apply vendor patches and implement secure policies and/or system hardening. In terms of SDLC, focus on JAD and lean development to get the best of both worlds. And finally, establish a security-focused protocol, policy, and development methods at each stage of the software development lifecycle.